St. Petersburg is located at the delta of the wide and deep Neva River that originates from the uniquely clean Ladoga Lake. Water has never been in short supply here. However, as a consequence of 300 years of economic activity, the water in the river has lost its original purity. Now it is being recovered due to the activities of the St. Petersburg Water Canal enterprise. All kinds of water analysis are performed for water canal by the Water Research and Control Center that was established in 1991. However, it was only in 2002 that all laboratories and divisions previously scattered across the whole city were placed in a single building at 9 Komsomola Street. This building required sophisticated engineering. It was designed in a special project and requires special maintenance. The building houses executives and service departments, as well as laboratories equipped with state-of-the-art analytical equipment. 170 people work at the center, carrying out more than 600,000 analyses per year, measuring hundreds of characteristics. This film briefly describes the organization of analytical research at the center, as well as the process of interaction with customers. Interaction between the center and Water Canal Enterprise is based on a contract and approved technical specifications, which list monitored locations, contain detailed control schedules, and prescribe specific measurement methods. All technical specifications are entered into the FavorData software, thereby automating the entire production process. 40 transport routes have been designed to take samples from 370 locations around the city. Sampling jars are labeled with barcodes for each group of characteristics. Jars for each monitoring location are then placed in thermostatically controlled carrying cases that are loaded onto vehicles. Once water samples are taken at the monitoring locations, operators deliver them to the center and present them to an operations officer. The operations officers register each sample in the FavorData software simply by scanning the barcode of the sampling location from every carrying case. Then, the barcode from each jar is scanned, and a work assignment for each workstation in the building is automatically generated with each sample identified by a barcode. After registration, the jars with samples are transported to the laboratories. The biological laboratory checks water samples for sanitary, microbiological, viral, parasitological characteristics. Species of phyto and zooplankton are identified. In the express analysis and chemical methods laboratories, the classical chemical photometric, titrimetric, and gravimetric methods are used. The main integral properties are determined here, including color index, turbidity, oxidizability, pH, and suspended matter content. Content of oil derivatives is determined with both gravimetric method and with infrared Fourier spectrometer. The chromatographic laboratory, using modern gas and liquid chromatographs and chromatomass spectrometers, measures the concentration of organic compounds, including polyaromatic hydrocarbons, pesticides, polychlorinated biphenyls, and dioxins. The spectral laboratory can measure concentrations of practically all elements of Mendeleev's periodic table using emission spectrometers and mass spectrometers with ionization in inductively coupled plasma. In the radiochemical laboratory, alpha, beta, and gamma radiation is measured, as well as radionuclide composition of samples. In the capillary electrophoresis laboratory, the most advanced technologies are used to measure the levels of ammonium ions, total organic and inorganic carbon, total nitrogen, concentrations of chlorides, nitrites, nitrates, sulfates, and other anions. As you can see, measurement of the characteristics in a single sample is carried out in parallel at multiple workstations. Once measurement is completed, technicians log into the FavorData software with their personal passwords, scan the barcode of a sample, and record the measurement results to the database. Where multiple characteristics are determined at one workstation, the results are automatically imported from the analytical equipment. The identity of the sampling location is never known to the laboratory technician, ensuring the anonymity of samples and impartiality of analysis. An official report with results for each sample is generated automatically and may be printed out by an operator, but not before all measurements required for the specific sample are completed. All information on sampling and analytical results is stored on the servers. Within a few minutes, all new measurement results are transmitted to a database at Water Canal Enterprise, where FavorData software is also used at more than 200 workstations across the city. Any value exceeding the maximum permissible level for any characteristic is immediately displayed at relevant workstation of the Department of Potable Water Production, accompanied by both visual and audio alarms. The staff of Water Canal Enterprise uses the data accumulated over several years for statistical analysis. The FavorData software also generates water quality maps of the city and its suburbs for any month of the year, for any week of last month, and any day of last week. Locations where values exceed the maximum permissible levels are painted red. Other colors are ranked accordingly. The exact address of the location can be displayed, as well as the degree to which the maximum permissible level was exceeded. Reports detail changes in a specific characteristic or group of characteristics within a selected period of time, as well as summary and average values. This system of analytical monitoring of water quality, which has been jointly developed by Water Canal Enterprise and the Water Research and Control Center using the advanced FavorData software, is an important factor in providing the 5 million residents of the city of St. Petersburg with pure and safe water.